With everything that you've learned in these live lessons, how to build deep learning networks and how to calibrate them properly, the various options that you have, you've probably started to have inklings of ideas of problems that you'd like to solve yourself, perhaps with new data or tackling fun projects for home use or at work. So when you're getting started thinking about your own deep learning project, here are 7 steps that you can follow to ensure that you really are doing something novel and exciting. The first thing that you need to do is define your task. So throughout these live lessons, we've been classifying images, but you may be interested in identifying objects of interest in an image or recognizing faces, doing sentiment analysis with natural language processing. There are a large number of possibilities. So make sure you have a clearly defined idea to get started with. Once you have that, you can define your data set. So the easiest thing here is to search for relevant academic data sets. So often for many classes of deep learning problems, there are already conferences that have come together to define large data sets, and conveniently they already have baselines for those data sets. So good examples that we've been working with in our classification tasks are the MNIST data, the Oxford Flowers data, CFAR 10 or 100, ImageNet. If the academic data sets available for the problem that you're trying to tackle don't suit your needs, then you can define your own data set. To do that, you can scrape images or text yourself from the internet, or perhaps from some proprietary commercial data set that you have at your work. Evaluation, when you define your own data set, is a little bit trickier because there are no existing baselines, but we'll figure out how to have some baselines ourselves later on in these steps. So with the data and the task in mind, you need to define some kind of metric to evaluate your performance on. Throughout these live lessons, we've been focusing on accuracy, just plain old classification accuracy, and that's perfectly suitable to many types of tasks. There might be some kinds of tasks that have a specialized metric depending on the problem that you're trying to solve. So you can have a look online and see if there's some more appropriate metric than accuracy for your specific problem. The next step is to split your data set. So throughout these live lessons, we've had a training set that was most of our data. So with the 70,000 MNIST digits, we were using 60,000 of them to train on and 10,000 of them to validate. We've been using the term test and validate as synonyms, but when you're building a really big project that you want to evaluate rigorously, they actually mean 2 different things. So you want to split your data set into 3, not just into 2. You want to have your training set that might be anywhere from 60 to 80% of all of the data that you have, and then a validation set that's more like 10 or 20% of the data. And that's what we've been using throughout these live lessons to monitor your accuracy on data that are unseen to the model. The problem is that when you've been working with your model a lot and you've started tuning so many different hyperparameters yourself, you can start tuning to that validation set. So you want to have a second holdout data set that's the proper test set. This might be just 10% of your data, but you want to evaluate your model performance on this test set rarely. Certainly no more than once a week, ideally no more than once a month. That way you can be sure that you're not tricking yourself into thinking that you have a great model. You actually know. With that test set, you can establish a really firm baseline. So you may want to establish your baseline by implementing a really simple machine learning model like a logistic regression model first. And then you can compute your metrics on your test set, and you can see how your neural network performs against it. if the results at this stage are very good, so for example, if you can with a logistic regression correctly classify most of your data, then this problem may be too easy for a neural network and should head back to the top and start again with a more complex project. Once you have your baseline with some simpler kind of model, then you'll want to implement an existing neural net model. So you can use somebody else's architecture that you find online to compute your performance on your training and your validation sets. So that's the kind of modeling that we've been doing throughout these live lessons. You want to analyze your output, see where your errors are in your code, and after you have that all set, then you want to improve your model following all the steps that we covered in the previous section.